A transmission media can be anything that can carry a message from a sender to a receiver. Examples of a transmission media include air and a coaxial cable. For example, in radio broadcasting transmission and reception, the medium of transmission is air, whereas in cable television, the medium of transmission is a coaxial cable. Now we come to the different classes of transmission media. Transmission media can be classified into guided transmission media and unguided transmission media. Guided transmission media includes a twisted pair of wires, coaxial cable or fiber optic cable, whereas unguided transmission media include radio waves, microwaves, infrared and free space optics. So in guided transmission media, the transmission media will be in a physical form, whereas in unguided transmission media it can be free space. Guided transmission media provides a physical conduit from one device to another. It can be metallic or non-metallic such as glass. Examples of metallic guided media include twisted pair, coaxial cable, and examples of non-metallic media or glass media include fiber optic cables. Guided media can be shielded or unshielded. Shielding prevents penetration of noise into the transmission media. On the contrary, unshielded twisted pairs of wires are used in telephone applications. Unguided or wireless transmission media do not have any physical conductor such as copper for transmission. It uses free space and propagates frequencies ranging from 3 kHz to 900 terahertz. So wireless transmission media are classified into radio waves, microwaves and infrared. So frequencies from 3 kHz to 1 GHz are used for radio wave transmission, and it is a known line of sight transmission. Microwaves range from 1 to 300 GHz, and it is a line of sight propagation method. Infrared also is a line of sight propagation method, and it uses frequencies ranging from 300 kHz to 400 terahertz. So infrared, again, it cannot bend over obstacles. Microwaves are used for point to point communication, as well as infrared waves, which are again used for line of sight point to point communication. Radio waves have omnidirectional properties, which means that the transmitter and receiving antennas need not be aligned and within the line of sight. We will see some of the examples of a guided transmission media. The twisted pair of wires, for example, the unshielded twisted pair cable have a maximum bandwidth of 100 megabits per second. The transmission distance is 100 meters maximum, and it is used in local area networks. Biaxial cables for use in cable TV networks have a maximum bandwidth of 10 megabits per second and a transmission distance of 185 meter maximum. This means that coaxial cables are used for long distance transmissions. Now we come to fiber optic cables. Fiber optic cables are used for long distance network cabling. The maximum bandwidth can be 10 gigabits per second. The transmission distance can be many miles. So we can see the advantages of guided transmission media, especially the fiber optic cables. So they have large bandwidth. They can be used for long distance transmission. A fiber optic cable has a glass or plastic core and cladding, where cladding is less dense when compared to core. Here light is guided through the core of the optical fiber, and the phenomena involved is a total internal reflection, where when a light is guided through the core, It undergoes total internal reflection at the core cladding interface, and it travels through within the core without much loss. Current technology of optical fibers supports two modes, multi-mode and single mode. So multi-mode fibers can be step index fibers or graded index fibers. Multi-mode is named so because multiple beams from a light source move through the core through different paths. How these beams move within the cable depends on the structure of the core. In multi-mode step index fiber, the density of the core remains constant from center to the edges. A beam of light moves through this constant density in a straight line until it reaches the interface of the core and the cladding, wherein at the interface there is an abrupt change due to a low density and alters the beam's motion. The term step index refers to the suddenness of the change from core to cladding. In multi-mode graded index fibers, as we can see that the index of refraction is related to the density. Density will be highest at the center of the core and decreases gradually to the lowest at the edge. A single mode fibers uses a step index and a highly focused source of light that limits the beams to a small range of angles or close to the horizontal. The decrease in density results in a critical angle that is close enough to 90 degrees to make the propagation of beams almost horizontal. The propagation of different beams in single mode fiber is almost identical. All the beams arrive at the destination together and can be recombined with little distortion to the signal. Thank you for your patient listening.